Hello, my name is Jared. This is Naveen, Shazib, and Joshua. We work on the Reactive Insulin pump. Me and Naveen work on the software side, and Shazib and Joshua work on the hardware side. Currently, our project is focused on type 1 diabetics who use active insulin therapy and how their system is outdated, in which we propose using a automated system to fix these human errors, such as inputting insulin through an insulin pump. And our project is comprised of 4 main components, in which I will pass to Shazib to talk about.
Yeah, so in industry today, a lot of people, if they're eating something or they're going to eat something later, they have to prepare to manually inject insulin into their body. Our system is going to be completely autonomous, and the way that happens is we have 4 major components. We have an insulin pump. That's a industry standard insulin pump from Medtronic. We have a constant glucose monitor, which is in charge of just measuring your glucose levels. We have a microcontroller that does all the processing and algorithms we got from different endocrinologists over the semester, and a mobile application which acts as a monitoring tool for all errors that may occur during the process. It contains redundancies and warnings, and it tells you when your insulin is actually being pumped into your body. So the challenge here was the insulin pump that we have is an industry standard insulin pump. When we went over to Medtronic to get some help on our project, they basically said, no, we can't help you, you're on your own. We're not giving you any trade secrets. So the main challenge was, okay, reverse engineering the insulin pump, figuring out what frequencies are the insulin pump actually sending out. And to do that, we did a lot of very unconventional methods, such as reaching out to ex-employees and different documentations. It worked. So our system basically we have algorithms from endocrinologists saying if your glucose level is above 70 milligrams per deciliter or below 240 milligrams per deciliter, you're going to get dosage automatically inputted into your body via the insulin pump. And that insulin pump is connected to your body via cannula, going straight to your pancreas. Our constant glucose monitor is going to be on your arm. It's constantly measuring your glucose levels and sending the data out to our microcontroller, and then the microcontroller is sending it to our mobile application via an app we made via Bluetooth. And those are about the main 4 components, and that's our project.
Just had a question about the, you said you have fully developed safety features. Could you detail what those are?
So the nice thing about our project is
critical,
we weren't working with a completely proprietary technology. So we had the redundancies that were already inside of the CGM, the constant glucose monitor, and the pump. So on top of that, to start off with, the pump itself won't let you implement over a certain amount of insulin into your body. So if you try to set 25 units, it won't let you go over a maximum of 10. So you can't overdose on insulin. So that's a nice thing that the pump kept us from. And you have to input settings into there for there's 2 different algorithms, the bolus and basal. Both of those have a set amount of insulin that you can set into your body in a certain day, and your pump will act based off of that. And if the pump notices that you're not actively inputting insulin based on the regimen that you put into the physical pump, it will start sending you updates there. And we're pulling notifications from the pump as well as from the CGM. So not only will you be getting these notifications on the pump, we'll also be outputting back to your phone. So you're getting the mobile application showing you that, oh, there's these warnings that you're getting from the pump that it's noticing. And then from the same side over from the CGM, which the company that we're sponsoring is Dexcom, so they have a very intuitive app that we can also mimic their notifications for, hey, your blood glucose levels are too low, they're a little too high, et cetera, et cetera. The redundancies that that come specifically for our mobile application is that if we start noticing some inaccuracies or odd behavior, we'll send you a notification like, hey, we see this is happening, you should probably check on that. If it continues and so on and so forth, because of the limitations, we're not, if it goes to an extreme that the mobile application notices, we cannot call 911, but we allowed you to put emergency service numbers inside of your phone. So if it notices you've gone past a certain point that you're not implementing insulin, your blood glucose levels are too low, it will let your next of kin or whoever you decide to input into the settings as your emergency contacts.
So our closed loop system is approved by the FDA today?
No, we're working outside of the FDA approval.
Does this require like a tube going from your pancreas to a port?
Not your pancreas. It's just to your body. So a regular a cannula just attaches to your body and implemented just on top of your skin.
What is that, just kind of a needle looking?
It's just a little needle, yeah.
You guys said that the cost efficiency right there said not to exceed the budget of $2,000. Is that a cap, or is that basically a market comparison? In other words, is what that price is compared to other devices that are on the market?
Yeah, market comparisons right now go up to $3,900 for similar systems, but the only thing is because that they're still working on FDA approval for closed loop systems, they're keeping it extremely selective. So if you wanted to be a part of that system with some sort of monitoring from specific companies, it's very hard to get there. So we're offering a cheaper solution because we're taking advantage of the common pumps that many people already have.
So your application currently is monitor only? Or-
Monitor and input. So if it will automatically check on your glucose levels, and if it is above a certain range that you put into your settings or below, it will notify the pump to automatically input a certain amount based on our algorithms for the dosage recommendations.
So those algorithms and those guidelines, did you think about as you do this closed loop system what 5K, 10K would look like, or any preparation thought about that as you mentioned?
I'm sorry, I didn't.
Meaning, when you built your algorithm, did you keep in mind some of the FDA guidelines that would have to go?
Yeah, we referenced published papers as well as endocrinologists that live in the area. So these are common dosage algorithms that people are using to manually input. So we're using common knowledge algorithms for type 1 diabetics.
Okay.
Did you have any constraints for security to prevent hacking?
The major security constraints, we didn't get a chance to implement those physically, so technically you kind of open, that's kind of how we were able to build our project, essentially. So the pump comes with a transceiver, so we're basically sending information to the pump via that transceiver. But in the same right, if someone wanted to hack your pump from a close distance or something like that, they could do it the same way.
The pump works in the ISM band, that's like an open band, so 960 megahertz. If you really wanted to go within the person and actually mess up their insulin pump, there's ways to do it, but.
Yeah, the lack of safety is how we were actually able to do our project, so.
Let's thank the team.